Okay, welcome back to our statics video. I was cut off at the end of the last video. I ran up against my 15-minute time limit. That really irritates me because I was almost done with the boom. So what we were doing in the last video is analyzing this frame, and we started with the boom and found that CH and DH, we don't know what they are yet, but we do know that they're going to be equal to each other. We found dV is 15,050. We're using the author's convention of using V and H for vertical and horizontal. So V is the vertical component, 15,050. And then we were just about to find CV, which would have finished this analysis of the boom, and then we could have ended the video and moved on to the next frame member, and we just didn't quite make it in time. So we were summing all of the forces in the y direction, or maybe I should say in the vertical direction, to use the author's notation there. And so it's going to be equal to 1500. Now you do have to pay attention to the sign here when you solve these. I sometimes kind of do multiple algebraic steps in my head as I'm solving these out, so I should maybe be a little bit more deliberate in my solution here. So CV was negative. I'm going to take that over to the other side of the equation by adding CV to both sides. And so the other terms here on the right side of the equation are going to keep their same sign. I'm not moving them. They're staying in place. So that's negative 1500 plus 15,050 minus 10,000. So negative, positive, and negative. And so CV equals 3350 pounds. And so the reason why we need to be so careful about plus and minus signs and make sure we don't accidentally flip anything is because the fact that these answers are all turning out, well, these two answers are turning out to be positive is important. That means that our assumption about their direction was correct, that dV is in fact pushing the boom up and CV is pulling it down. If we had solved either of these algebraic equations and gotten a negative answer, the number itself would have still been correct, but then we would have had to have flipped the arrow. Instead of going down, it would be up, or over here, instead of going up, it would be down. So you do have to make sure that you are very careful and deliberate about the sign of the numbers when solving these equations. So now we're done with the boom. We have found all we can find here. We've got this little note to ourselves that CH is equal to DH, and now we can move on. So we've chosen to go to the brace next. We probably could have gone to the post, but we've chosen to do the brace. There's no definitive right way to do it. You can go in a different order and probably come up with an equally valid solution. We're just going to remain consistent with the textbook solution, though, and go to the brace next. So what we have going on here is we have pin D at one end and pin E at the other, and we have the weight of the boom. Now we were told that the weight of the boom, or not the boom, the brace, now we're talking about the brace, the weight of the brace is 900 pounds coming down, and that's at the midpoint of the brace, which had a horizontal distance of 10. So it's 5 feet over from joint E, 5 feet over as well from joint D. Now, in the previous free body diagram, when we did look at the boom, we found that joint D was pushing up against the boom. So we've got the boom, and joint D was pushing that boom up with a force of 15,050. That's what holds it up. We had the 10,000 pound force here at the end trying to pull it down. So the joint is pushing the boom up. If it's pushing up against the boom, that means it's doing the opposite thing against the brace. It's pushing down against the brace. So that's perhaps one of the harder things to conceptualize when you start doing frame analysis, is understanding the sense that these forces have. And so we have to think about the joint affecting the frame member, and have to keep in mind that if that joint is pushing up against the boom, it must be pushing down against the brace. Those two forces have to cancel each other out. So that 15,050 that we found in the previous free body diagram, we can write that down here. We know what this force is, the vertical force at D, but now its sense is in the opposite direction. It's pushing down. And that makes sense because this brace, in the overall shape of this frame, that brace is in compression. We've got this externally applied load here that's trying to bring the boom down. The brace is going to be in compression. It's going to be compressed or pressed together. So that's what that 15,050 pound force is doing. Okay. DH, when we analyzed the boom, we didn't know what DH was, but we know whatever DH is, it's equal to CH. And again, when we analyzed the boom, the horizontal boom, we said that DH was pushing the boom to the right. So that just means that when we look at the other framing member that's connected by that pin, the sense is going to be opposite. Now DH is going to the left. We still don't know what it is. We know it's going to be equal to CH, and we know it's going to be going to the left. Then we've got the weight coming down, and then we've got how is joint E going to affect this diagonal brace. So DH, if DH is pushing to the left, EH must be pushing to the right. It must be canceling that out. So what I can do here is let's sum those forces in the x direction. Let's do that first. That's going to equal 0. Or I could use H here for horizontal. That's what the textbook author does. And so what are those forces in the x direction, in the horizontal direction? Well, I've got EH going to the right, and I've got DH going to the left. So we run into a similar issue here where we don't know yet what EH or DH are, but if we solve this equation for one of the variables, DH is equal to EH. Okay, so again, we don't know what either of them are, but we do know that they're going to be equal to each other. And that's really as much as we can say right now. So we'll move on, and we'll come back to that. In the vertical direction, we have this known force. We found that by analyzing the boom. We know the weight that was given in the problem statement, and we have this vertical reaction at E. That's the only unknown variable in the vertical direction. So if we sum the forces in the y direction, or the vertical direction, as the author says, then we know those will all cancel out. So that means we've got negative 15,050, we have negative 900, and we have positive E in the vertical direction. Those three forces will cancel out to be 0. So that means that EV is going to be equal to 15,050 plus 900. So that is 15,950 pounds. Okay, so that's 15,950. So there's one of our pin reaction forces found. Check that one off the list. We know that one. We know DH and EH are equal to each other. We just don't know what either of them are yet. But here's where we can find out what one of them is. If we were to sum the moments about E or sum the moments about D, we could find the other force, the horizontal force at the opposite joint. So I'm going to sum the moments about E in order to find DH. If I sum the moments about E, let's see how many moments there are. So the forces that actually pass through E don't cause a moment. I can ignore both of those. I have the 900-pound force. Its moment arm, since it's a vertical force, the moment arm is the horizontal distance of 5 feet. And it's going to cause clockwise or negative rotation. Then we also have, in the clockwise direction, this 15,050. It has a moment arm distance of 10. It's a vertical force, so the horizontal moment arm distance is 10. And in the opposite direction, DH is going to go around in the counterclockwise direction. So it's positive DH times its vertical moment arm distance of 10. So DH is equal to 900 times 5 plus 15,050 times 10, and all of that divided by 10. So DH is equal to 15,500 pounds. Okay, and if DH is 15,500, let me fix that. 15,500 pounds, that's better. DH is 15,500 pounds. That means EH is also 15,500 pounds. And if we go back to the boom, that means that CH was also 15,500 pounds, because we had said earlier that DH and CH are equal to each other. So this is the point where we finally found that key piece of information, and then we can circle back to the boom. We left this just saying that these two things were equal to each other, but we didn't know what they were. Well, now we do. 15,500. And DH here, 15,500. So now we know. So that's just an example of how this process of frame analysis is not always linear. Sometimes we have to move ahead and then come back and then move ahead again until we finally fill in all those blanks. So we're done with the brace now. We've found all the information we can find by analyzing the brace, and that leaves just one frame member to go, the post. So we will do our analysis of the post in the next video. This is a great place to stop.